Hello everyone, today we're going to be going over the new Geometry Regents exam. For those of you that don't know, the Regents board has made changes to the Geometry Regents exam. So in this video, we're going to be talking about what those changes are, what the new test looks like, and possibly some new questions that can show up on your exam. Right, so in terms of what has changed for this test, the format has stayed the same, right? It's still going to be 35 questions in total, still 24 multiple choice questions worth 2 points, 7 short response questions worth 2 points, 3 short response questions worth 4 points, and 1 final question worth 6 points. Again, that hasn't changed. What has changed, however, is the reference tables, right? This is the old Regents geometry reference table. We have a lot of conversions here, and then we have some algebra and radian conversions here. But the new reference table just only has your volume formulas, right? So if you were relying on the formula, the reference table for the Pythagorean theorem or the quadratic formula, or converting radians to degrees and vice versa, well, guess what? You need to memorize those formulas now because the reference sheet has changed. Okay, so the way that the test looks hasn't really changed that much, right? It's still the same number of questions. The reference tables are different, but the main difference is the types of questions that they will ask you. And the Regents has provided us with these types of questions here, right? So these are all examples of some brand new questions that you may encounter when you're taking this brand new Regents exam, okay? So we're going to go ahead and start off with number 1. So it asks us which series or sequence of rigid motions will map triangle ABC onto triangle DEF. Okay, so here we have triangle A, should I get a straight line A, B, and C. Okay, and here we have triangle DEF, and we're trying to move ABC onto DEF. Now, if it's a little bit hard to see, I don't know why the Regents didn't highlight the axes, but this is the y-axis, and this is the x-axis. So hopefully this makes it a little bit easier for you guys to see the axes. Right. All right, so now we just are going to go through these answer choices and see whichever one correctly maps this triangle onto this triangle right here. All right, so the first answer, or the first choice, says that we have to translate 4 units down followed by a reflection over the y-axis. So let's see whether that's valid or not. If I were to translate this 4 units down, I'm just moving every single point 4 units down, or I'm subtracting from the y-coordinates 4 units. So I'll go 1, 2, 3, 4. That's a translation 4 units down, okay? So remember that this right here is point C. This right here is point C, and this point right here is point B. Now, if I were to reflect this over the y-axis, that would be incorrect. Why? Well, look, I'm mapping triangle ABC onto DEF, and the reason why I highlighted specifically the letters is because point A has to map onto point D. Point B has to map directly onto point E, and point C has to map directly onto point F. That's just a rule, right? You can see the relationship between the sides and the vertices in the two names of the triangle, right? So triangle A, B, C. A is the first letter. That means that A has to correspond with letter D in DEF, right? First letter goes with first letter. First vertice. Second vertice, third with third, okay? And this is a trick that goes also for the side lengths. Side AB corresponds to side DE. Side BC corresponds to side EF, okay? Now, the reason why I bring this up is if I were to reflect this over this point, I'm literally just bringing whatever's on here onto this side. But look what I'm bringing. I'm mapping point C onto point E. Remember, I want point C to go to point F, not to point E. So this is wrong because the reflection doesn't map the points on correctly. The shape is there. Technically, you do map this triangle onto this triangle, but not in the correct orientation, which is everything that rigid motions are, right? That's the thing that matters the most, okay? Now, choice 3 says it's a translation 2 units to the left, followed by a reflection over the x-axis. So let's go ahead and let's see what that looks like, okay? So I'm going to move my triangle back up to where it started, up here. And I'm going to move it 2 units to the left. So that's 1, 2. And then if I reflect that over the x-axis, well, my shape will just end up down here. That didn't map onto DEF. That's nowhere near DEF. Okay, so that's why this is also the incorrect answer choice here. Right? Now, choice 2 says that, well, this rigid motion is a point reflection over 0, 2. Now, how do we figure out what a point reflection is? Well, we figure out what the point reflection is by drawing lines that connect each one of the vertices together and seeing where those lines intersect. I've went ahead and I've drawn lines that connect the points that correspond to one another. So I have a line between A and D, a line between B and E, and a line between F and C. And essentially, if a point reflection was responsible for this change, the lines should add up or should all intersect at the point that I've just drawn here, right? And if we look at where they intersect, remember that this is the x-axis over here. I don't know why they didn't bold it for you guys, but let me just highlight it for you guys. This is the x-axis. So if we count, that's 1, 2 points above the x-axis, which is the point 0, 2, which is why choice 2 has to be correct. So remember, the rule with the point reflection is if you draw lines that connect all of the corresponding vertices, their point of intersection is the point of reflection, okay? The reason why choice 2 is wrong is because if you were to reflect this triangle over the line negative x plus 2, which is something along a line that kind of crosses over like this, your resulting shape will end up, just visually, you can see that your shape will probably end up like this, and it'll be rotated like that, right? You'll end up somewhere over here, okay? Which obviously is not where you want DEF, okay? Moving on to number 2, it says in right triangle ABC below, the measure of angle C is 90, the measure of angle B is 30, and CB is equal to 6 radical 3. So any single time, or every time that I have a right triangle and I'm given an angle, theta, and a random side, in this case CB, and I'm trying to solve for another side, I'm going to think immediately to my trig functions, okay? So sine, cosine, and tangent. All right. If you need a way to remember what sine, cosine, and tangent are, remember SO, ca, TOA, right? Sine is equal to OH, or opposite over hypotenuse. Cosine is equal to the adjacent side of the hypotenuse. That's what the AH is. And tangent is equal to the opposite side over the adjacent side. Okay, so now you might be asking me, well, what is the opposite? What is the adjacent? Well, the easiest one to prove here is the hypotenuse. The hypotenuse is the side that is opposite of the 90-degree angle. So this is my hypotenuse. Okay? In other words, it's as if I drew a straight line going from this corner right here. All right? The opposite side is the side that is opposite the angle, right? So if I were to draw a straight line going directly out from this angle, guess what? It would hit this side right here. So this is my opposite. And finally, my adjacent is whatever side the angle is hugging. Now you might be saying, well, this 30 degrees is hugging angle H, sorry, side H, which is my hypotenuse, and 6 radical 3, which one's my adjacent? Well, it has to be 6 radical 3 because the hypotenuse is already defined, okay? Do not use your hypotenuse as an adjacent side. That's a common trick or a common mistake people do. So the way to avoid that mistake is to always label your hypotenuse first by going and figuring out which side is opposite the 90-degree angle. If you already said the side is the hypotenuse, it cannot be the adjacent side, so this is the adjacent side. Now, what am I trying to solve for here? I'm solving for AB, which is my hypotenuse, so I'm not going to use the tangent function because that one doesn't even have the hypotenuse in it. Now, I'm given the adjacent side, and I'm not given the opposite side. I need at least one side to solve for this, so I'm not going to use sine either because I don't have my opposite. So now I can use cosine. So I'm going to find that the cosine of 30 is equal to the adjacent side, which is 6 radical 3, divided by my hypotenuse h. Okay? Now what I'm going to do is I'm going to cross multiply. Cosine of 30 is equal to cosine of 30 over 1. Same thing. Then I'm going to multiply this bottom by this top over here. So I have h times the cosine of 30 is equal to 6 radical 3, and then all I have to do to solve for my hypotenuse, which is AB in this case, is to divide both sides by the cosine of 30. And now I get that my hypotenuse is equal to 12, which is choice 3. All right, moving on to number 3, it says in a non-right triangle ABC, shown below, AC is equal to 5, BC is equal to 8, and the measure of angle C is equal to 57 degrees. They want us to find the area. Now, whenever you're given an angle between two sides of a non-right triangle, okay, you can use the formula that the area is equal to 1/2 AB times the sine of C, okay? So A and B are the two sides, and C is the angle. It's going to be the angle between those two sides, okay? So we can just plug this into our formula that the area is equal to 1/2 times 5 times 8 times the sine of 57, and that's going to give you choice 2, all right? So very, very important function or formula that you guys need to remember here, all right, for non-right triangle area specifically. All right, let's say you forgot this formula though. What could you have done? Well, what you could have done was you could have realized that the area of a triangle is equal to its altitude, well, I'll just call that A, times its base, times 1/2, right? So the altitude is kind of the height of the triangle. It's as if you drew a perpendicular line from one of the vertices going down. So this is the altitude. If it forms a right angle with the base that it touches, okay? This could have been another altitude of this triangle right here, if it formed a 90-degree angle with whatever side it touched. And this right here could have been another altitude, again if it formed a 90-degree angle with whatever side it touched. Okay, so as long as you multiply any one of these altitudes by the base, you would have gotten the area, as long as you multiplied it by 1/2 as well. So what I'm trying to get at here is, even if you forgot this formula, you could have just drawn an altitude in and solved for it like that. So let's say that this is my altitude, this is a 90-degree angle. I want to solve for my altitude, which is x, and I have an angle here. So if I'm given an angle, I'm given a side, and I want to solve for another side in a right triangle, because technically this altitude has to be perpendicular, meaning that there's a right angle here, meaning that this whole thing is a right triangle. Guess what? I can look back at my sine, cosine, and tangent functions, right? In this case, I'm solving for what? I'm solving for my opposite side. So my x is my opposite side. I know that my 5 inches right here is my hypotenuse. So which one of the trigonometric functions relates the hypotenuse with the opposite? Oh, SOH, or that the sine of theta, or the sine of that degree, is equal to the opposite side over the hypotenuse, okay? So I can say that the sine of 57 is equal to the opposite, which is x, divided by the hypotenuse, which is 5. And now I know that 5 times the sine of 57 degrees is equal to the altitude, okay? And I can plug that altitude into this formula now. I can do 5 times the sine of 57, which is my altitude, okay, times my base, which is 8 inches. I'm not going to use 5 because 5 isn't my base. 8 is my base. The way that you know which side to use for your base is whichever side the altitude touches. So I'm going to multiply that by 8, and I'm going to multiply that by 1/2, and I'm still going to be left with 16.8. Okay, so even if you forgot this formula, you could have still solved it just by drawing in your own altitude. So that's 2 ways that you could have done this problem. All right, number 4 says that circle P has a center of 3, 2, and it's passing through A, which has a point of 0, 6. Right, and they're asking us for the equation of the circle. So the equation of a circle is going to be given by x minus h squared plus y minus k squared is equal to r squared. So the center of this circle is represented by the point h comma k. All right, so right now we know that the circle has a center of 3, 2. So 3, 2. That means that my h is equal to 3, my k is equal to 2, right? That's just the place that it takes. The h is the x coordinate of the center, the k is the y coordinate of the center. So I can rewrite this as x minus 3 squared plus y minus 2 squared, and that's equal to my radius squared. Now remember, the radius is the distance from the center, which they said was p, to any edge of this circle. And the easiest way to find the center is just to go to the left, or to go to the right, or to go up, or to go down from the center. Okay, you don't want to go diagonally, because then you have to kind of use the Pythagorean theorem. It's a big mess. So my advice, literally just go to the right. Okay, I have to go 1, 2, 3, 4, 5 units to the right. So this side here is 5 units long. My radius has to be 5. 5 squared is 25. So now I know that x minus 3 squared plus y minus 2 squared is equal to 25, which is going to be choice 4 here. X minus 3, y minus 2, 25. Right? Number 5 says a triangle with vertices at -2, 3, 3, 6, and 2, 1 is graphed on this set of axes below. A horizontal stretch scale factor of 2 with respect to x equals 0 is represented by x, y gets turned into 2 times x, y. Graph the image of this triangle after the horizontal sketch on the set of axes below. So essentially, what's happening here is that they're stretching this image outwards, right? Let me see if I can show you that down here. So what they're doing is they're just selecting whatever image they just drew, and they're stretching it outwards like this, right? The y isn't changing at all, but the x, but the x is, right? So they're just stretching it out and just making this shape a lot longer, all right? Now, obviously you can't do that on your piece of paper because it's a physical exam, but what they did was they did it mathematically, right? I eyeballed it, but what they did was they took the point x, y, and they just decided to multiply 2 times the x coordinate, and then just slap on the old y coordinate there. So your job is to follow this transformation. Whenever you see 2 points with an arrow, that means that we're following this rule. This old point is being turned into this new point using this rule. In this case, the rule is 2 times x, y. So my first point, for example, -2, 3, right? And again, I'll highlight the axes for you so that it's a lot easier to see. So this is my y. This is my x. Okay, so the point -2, 3 is right here. What we're going to do to this is we're going to take x, y, which is 2, 3, and we're going to turn it into 2 times x, y. So this is my x. 2 times -2 is -4, and my y is 3. So now I have a new point, -4, 3. Okay, so -4, 3 is 1, 2, 3, 4, 3 is 1, 2, 3. It's out here, okay? And I'll draw that in a different color. Do that in blue. Okay. Then my second transformation, 3 comma 6, which is up here. This 3 comma 6, well, I have to multiply my x by 2, so 3 times 2 is 6, and 6 comma 6 is now the new coordinate of my point. So 1, 2, 3, this is 6, 6 from the origin, and then the y is also 6. Then finally, I need to do the same thing for this point right here, 2 comma 1. So if I have 2 comma 1, I'm going to multiply 2 by the x to get 4 comma 1, which is now going to be 1, 2, 3, 4 down here. And now all I have to do is just connect these 2 points to show them that I know what the shape is. So, sorry, that was a sloppily made point. So right here, we're going to connect these two like so. We're going to connect these 2 points like so with the straight line. And then finally, we're going to connect these 2 points with a straight line like so as well. Okay, and that's going to be my brand new triangle. We could see here how we just stretched it out, right? All we did was we just stretched the image following this rule. 6 wants us to use a compass and a straight edge to construct the circumcenter of triangle XYZ. So the circumcenter of a triangle is where the medians meet up. So the medians of a triangle are just the lines that you draw from each vertice to the opposite side. And these lines are supposed to split these two, the side that it intersects, into 2 equal halves, right? In other words, it bisects them. So if I were to draw all of the medians of this triangle, right, these 2 sides would be equal to each other. And finally, if we're drawing one from x all the way out here, it would make these 2 sides equal to one another. All right. Now, the circumcenter of this triangle is just the point at which all of these medians intersect, which is right here. Okay, and that's all you would have to do. Now, obviously, I eyeballed it. You cannot eyeball it on this test. What you have to do is you have to go ahead and use your straight edge and your compass to manually find the bisectors of these sides and then draw the point at which they intersect. So let's go ahead and let's do that in this software over here. So I'm going to bring out my protractor over here. I'm sorry if this software looks a bit silly. I couldn't find anywhere else that I could get a online compass and straight edge with. Anyways, you have 3 sides to work with. The only thing you really need to do here is you need to find the bisector of at least 2 sides. So I'm going to use side XZ as my first side, okay? Now, I'm going to place my compass, right? You have 2 ends, right? You have the metal end and you have the pencil end. I'm going to place the metal end of my compass down on the point, or the vertice X, making sure that my pencil end faces towards Z. And I'm pretty much going to extend my compass so that my pencil lies more than halfway across XZ. So here we can just kind of eyeball it. The midpoint of XZ is like somewhere over here. And now my compass is definitely more than halfway across. And then all you have to do from now is just draw an arc, right? Just swing an arc through that line, like so. Pretty much make like a semicircle. That's all. If you don't like your drawings to be too messy, you can, instead of drawing an entire semicircle, what you could do is you can just draw an arc above the line and an arc below the line. So you can draw an arc up here, and then you can draw an arc down here. But honestly, I prefer to just draw the full line because, you know, it's just easier to understand, and you make less errors that way. So now you're going to go ahead and you're going to move your compass to point Z. And then you're going to do the exact same thing. You're going to go ahead and you're going to draw a line like so up here, and you're going to swing your arc down here. Okay? And you can see here how you have 2 intersecting points up here and up here. Just congratulations, you've just drawn the bisector of this side XC. Okay, and you're going to connect those 2 points to show that bisector. Okay, so now you know that the distance between X and this intersection right here is the same as the distance between this intersection and Z. Okay, so remember that the circumcenter is going to be an intersection, or the point of intersection between all of these lines. So now we have to construct another one, and I'm going to go ahead and I'm going to do that on side YZ. You could do it on side XY, it doesn't really matter. I'm just going to do it on YZ. Okay, so I'm going to take my compass, I'm going to make sure that my pencil end is, again, more than halfway across, and I'm going to just create another arc going this way. Okay, again, if you don't like your page being messy, you can swing an arc here, stop, and then swing another arc down here, but I prefer to do the full circle. And then you're going to move your compass over here, and you're going to do the same exact thing, right? So you're going to swing it inwards like so, okay? So now we can see here how we, again, have these two intersections, these two curved x's. One's right here and the other one's right here. So I'm going to go ahead and I'm going to connect them with a straight line. Now on the Regents, obviously you don't have the software. What you would just have to do is you would have to arrange your straight edge between these 2 points and just use your ruler to connect them with a straight line. But that's it, right? We see here how these two intersect at this center point right here. So again, this point is going to be my circumcenter, which is right here. Okay, highlight it for you guys. I guess it doesn't let me highlight it, but again, that's how you construct it. Okay, you don't need to find the third median, because as long as you have two medians, you already know when all three of them are going to intersect. They're going to intersect at that point. So number 7 says, in the diagram below, triangle ABC is similar to triangle DEF. Okay, we know it's similar because of this symbol right here. This means similarity. This means congruency. This means that they're equal. This means that they're similar. Similarity just means that there's some sort of factor that I can multiply this smaller triangle by to get it to turn into this bigger triangle. Okay, so every single side is related by some sort of scale factor. Okay, now it's saying that AB is equal to 4 and that DE is equal to x plus 3. Okay, so that's this red side over here, and that's this red side over here. And then finally, we know that EF is equal to 15, which is down here. EF 15, and DE we already said was x plus 3, and BC, which is x plus 1. Or x minus 1, sorry. So I've labeled my sides, and notice here how I made AB and DE red and BC and EF green. Why? Because those two sides correspond to one another. Essentially what happens is ABC is just a smaller version of DEF, and there's some sort of scale factor or a number that I multiply AB, BC, and AC by to turn them into DE, EF, and DF, okay? Another way you could figure this out is by looking at the order of the letters, right? AB corresponds to DE because A is followed by B, D is followed by E, and then finally BC is corresponding to EF. So anyways, I can go ahead and I can draw or make some sort of relationship between them. So I know that if I divide side DE by AB, I know the scale factor, right? If DE was 12 and AB was 4, then I know that the scale factor is 3, because 12 divided by 4 is 3, okay? If side EF was 15 and BC was 5, well, guess what? That scale factor of 3 applies here. To get from this bigger triangle to the smaller triangle, divide everything by 3. Okay, so then I'm going to go ahead and I'm going to say that this is equal to EF, which is 15, divided by BC, which is BC. All right, and then I'm going to plug in values to that. So DE, we already said, was x plus 3, divided by AB, which is 4, and that's equal to EF, which is 15, divided by BC, which is x minus 1. So from here, all we have to do is we have to go ahead and cross multiply to solve for x. So here we have x plus 3, here we have x minus 1, so we're going to cross multiply them. That's x plus 3 times x minus 1, and then 4 times 15 is equal to 60. So unfortunately here we have to go ahead and solve this quadratic. So I'm going to factor, or I'm going to expand these two parentheses out. X times x is x squared, x times negative 1 is negative 1x or negative x. 3 times x is positive 3x, and then positive 3 times negative 1 is minus 3. And this is equal to 60. So here I have x squared plus 2x minus 3 is equal to 60. And I'm going to subtract 60 on both sides. Now I have x squared plus 2x minus 63 is equal to 0. And I've made it equal to 0 because now we can analyze, or we can FOIL this, right? So whenever you FOIL something, you're looking for two numbers. Here, I'll move this up here, guys. So whenever you FOIL this, you're looking for two numbers that can multiply and get you negative 3, but that add to get you positive 2. Okay, so, well, negative 63, isn't that just negative 9 times 7, or positive 9 times negative 7? Well, yeah, positive 9 times negative 7 is equal to negative 63. And positive 9 plus negative 7 is equal to positive 2. So those are the two numbers that I'm going to split this 2x into. All right? So we use negative 63 as a means to see or determine what those two numbers are, and then we actually split up 2x into those two numbers. So here I have x squared minus 7x plus 9x minus 63 is equal to 0. So again, I split up this 2x so that I can factor this. All right, because I want to split this up into two parentheses that are both equal to 0. All right, I can't split up something that has 3 terms into two parentheses. I need something with 4 terms to split it evenly in half. So now I'm going to take out a term that x squared and 7x have. That term is going to be x. So x squared divided by x is x, and negative 7x divided by x is just negative 7. Here, what term do 9 and negative 63 have in common? Well, it's just going to be 9. So I'm going to factor out a positive 9, and I'm going to get x minus 7. So this is all equal to 0. So now I have x plus 9 times x minus 7. I combine both of these parentheses into 1, and I combine both of these into another parentheses. This equal to 0. So now I have to see which value of x makes this whole thing equal to 0. So if x plus 9 is equal to 0, that means that x has to equal to negative 9. And finally, if x minus 7 is equal to 0, that means that x has to equal to 7. Okay, so the issue here is that you can't have a negative distance in geometry, so we're not going to use x equals 9. We're going to use x equals 7 in this case. All right, so now they're not asking for x. So you can't just say 7 is your answer. They're asking you for the length of DE. So the length of DE is 7 plus 3, which is actually 10. So the length of DE has to be 10. Okay, so number 8, which is the last problem here, says that hexagon ABCDEF with coordinates A at 0, 6, that's important, so 0, 6, B with coordinates at 3, 3, C with coordinates at 3, 1, D coordinates 0, 2, and E with coordinates negative 3, 1, and F with coordinates negative 3, 3. Graphed below, they want us to state the perimeter of this shape. So the perimeter is just the sum of all the sides combined. Okay, so I'm just going to find the value of all of these sides and combine them. So this is pretty easy because we know that BC is equal to 2. You just 2 units down to get from B to C. Same thing goes with point FE. You just go 2 units down. Okay. Now the difficulty starts when you look at points AF, AB, ED, and CD, right? The issue here is that they're a diagonal. So how do I find the distance of a diagonal? Well, I could just make a right triangle and solve for the hypotenuse. Look at it this way, right? If I want to find the distance between A and B, well, that's 1, 2, 3. That's 3 units that you have to go to the right by, and it's 3 units that you have to go down by. If you look at that, I've now just made a right triangle going like this. 3 units to the right and 3 units down, and they're connected by A, B right here. And I know that this is right triangle because literally it follows a grid. Each one of these grids are 90 degrees. Okay, so if this right triangle has one leg which is 3 units long, another leg that's 3 units long, I know that a squared plus b squared is equal to c squared. So 3 squared plus 3 squared has to equal to c squared. 9 plus 9 has to equal to c squared, and 18 has to equal to c squared. Now remember, I'm solving for c, not c squared, so I have to take the square root of both sides, and I get that radical 18 is equal to c. And the good thing is that each one of these sides is, again, one of these 3, 3 right triangles. So if I look at point CD, they're a part of 1, 2, 3. You have to go 3 units down. So the length of this leg is 3, and the length of this leg is also 3. Same thing with E and D, same thing with A and F, right? So I know that each one of these sides has a length of radical 18. The issue here is that I can't just say, well, the answer is 4 times radical 18 plus 4. Why can't I say that? Because that's not in radical simple form, right? Even though I know that all of these sides in blue are equal to radical 18, I have 4 of them, so that's 4 times radical 18 plus the 2 and the 2, which is 4. The issue is that's not in simplest radical form, so I need to convert this into simplest radical form, okay? So if I have 4 times radical 18, I'm only going to focus on whatever's on the inside of this radical, okay? When you want to do it in simplest radical form, you want to make sure that whatever's underneath the radical can't be split up into a perfect square. Now, can 18 be split up into a perfect square? Let's see. What are the factors of 18? Well, you can have 2 and 9. You can have 1 and 18. You can have 3 and 6. Oh, wait. I just went over a perfect square. 2 times radical 9. 2 isn't a perfect square, but radical 9 is a perfect square, right? So the radical 18 is actually equal to radical 2 times radical 9, okay? Remember that radical C is equal to radical A times radical B. Or if you have 2 square roots that you're multiplying, you can just combine them under the same square root symbol to multiply them, right? So you know that rad 18 is just equal to radical 2 times radical 9, right? Because radical 2 times 9 is equal to this, okay? The issue here is that radical 9, you can take that out of its square root symbol, right? The square root of 9 is 3. So now you have that the radical 18 is just equal to 3 times radical 2. So guess what? This 3 can't belong underneath this hat, so you move it to the outside. And guess what you have on the outside? You have a 4 on the outside. So now you know that radical 18 is just equal to radical 2 times 3, and then you have that 4 times. So you just multiply this by 4. Whenever you multiply a radical by a whole number, that's not another radical, you end up just sticking it to the outside of it. So there's already a 3 here, so you just do 4 times 3 to get 12 rad 2. So you have 12 rad 2 plus 4, and that's going to equal to your perimeter. That's the end of this video. If you have any questions, feel free to let me know in the comments below. If you like what you saw, please leave a like. And I hope you learned something, and I hope you have a nice day.